AI does not really live in the cloud. It lives in a global fight for tiny pieces of silicon. And the surprising part is who may end up paying for it. What if your next phone costs more because someone else asked an AI chatbot a question? It sounds absurd, but both depend on the same scarce ingredient: memory chips. AI data centers are buying them at a scale factories were never built to supply. Phones need memory, laptops need memory, cars, hospitals, and factories need it too. And here is the clue. One of the world's biggest memory makers nearly tripled its sales in 1 year without tripling production. It shipped only slightly more of its main memory product. Prices did the heavy lifting. So this is not just a technology story. It is a hidden price shock moving from server rooms into ordinary life. I built a model to answer 3 questions. How much is real demand? How much is price? And how long until new factories catch up? Start with the 3 kinds of memory. DRAM is the computer's workbench. It holds whatever the machine is using right now. More workbench, more work at once. NAND is the filing cabinet. It keeps your photos, apps, and documents after the power is off. Then there is high bandwidth memory, or HBM. That is the premium memory stacked beside an AI processor, so information can arrive at extreme speed. Think express elevators instead of stairs. HBM is valuable because it is hard to make. It consumes scarce factory space and requires extra steps to stack and connect the pieces. Memory companies naturally favor the product customers want most and will pay the most for. Today, that is often AI memory. But the factory still has only so many rooms, machines, and engineers. More capacity for AI can mean less for phones, laptops, cars, and industrial equipment. Different products, same manufacturing squeeze. Now, run the bakery test. Micron is one of the world's biggest memory makers. In its latest reported quarter, sales reached almost $24 billion. 1 year earlier, just over $8 billion. Sales nearly tripled. Production did not. For Micron's main working memory product, physical shipments rose only a few percent. The average price rose roughly 65%. Imagine a bakery selling 5% more bread while charging 65% more per loaf. Revenue explodes. The ovens barely speed up. That is what matters here. Price did far more work than volume. Storage memory was even stranger. Micron shipped slightly less, while average prices rose somewhere in the high 70s. Its adjusted gross margin reached almost 75%. In plain English, nearly $75 remained from every $100 of sales after direct production costs. Independent data point the same way. TrendForce estimated that common DRAM contract prices jumped roughly 93 to 98% in the first quarter. S&P Global found that one type of automotive memory was about 70% more expensive than a year earlier. This is no longer a quiet component shortage. It is a price shock. So why not build more factories? Because a chip factory is not a warehouse. It is a spotless laboratory the size of a small city. One dust particle can ruin a chip. The machines cost fortunes. The process has hundreds of steps. And a finished building is useless until it can produce good chips reliably. Chips start on wafers, shiny silicon disks holding many copies of a design. They must be cut, tested, and packaged. HBM adds the job of stacking and connecting several chips. Micron plans to spend more than $25 billion this financial year. Huge money. Slow result. Its first Idaho factory is not expected to produce initial wafers until the middle of 2027. Other projects come later. That is the mismatch. AI demand moves at internet speed. Semiconductor supply moves at construction speed. That gap is why today's shortage can survive tomorrow's investment. Now let me argue against myself, because memory booms have fooled people before. A shortage raises prices. High prices create profits. Profits attract factories. Customers panic and order extra chips. Then new supply arrives, warehouses fill, and prices fall. The cure for high prices is often high prices. Consumers can help break the cycle too. If phones and laptops cost too much, people wait. Manufacturers cut features or build fewer models. Demand weakens. Software offers another escape. AI developers are learning to compress the temporary memory used while a model answers questions. Think vacuum sealing clothes before packing a suitcase. Independent testing found that one method can roughly double that working space with little loss in quality. More aggressive compression can fit even more, but it can hurt speed or accuracy. There is one last twist. Efficiency makes AI cheaper. Cheaper AI gets used more. If each request needs less memory, but the world makes 10 times as many requests, total demand still rises. So efficiency can weaken the shortage or feed it. So here is where the evidence leaves us. The shortage is real. Prices are rising far faster than physical shipments. New factories are coming, but not quickly. That supports a longer squeeze. It does not prove a permanent one. 5 signals can break the story. Memory prices slow. Customers admit they ordered too much. AI companies reduce future commitments. New factories arrive early. Or expensive devices push consumers away. If none of that happens, the shortage has room to run. If several happen together, the roller coaster may already be near the top. That is the builder rule. Separate price from production. Separate a factory announcement from a working factory. And always ask what would prove the popular story wrong. For now, AI is competing with everyday products for the same memory-making system. The revolution may never send you an invoice. It may simply change the price tag on the next machine you buy. Full disclosure, I own Signal Finder Pro. This is general educational commentary, not personalized investment advice. Subscribe and we will update the verdict when the evidence changes.